Glycolysis literally means breaking of glucose. This makes sense because 6-carbon glucose molecule is oxidized to break in half to form two 3-carbon pyruvates. And to explain this in terms of overall equation, you have C6H12O6 that becomes two pyruvates, and pyruvates contain 3 carbons. So you can see that how C6 breaks into half to become pyruvates, and we're going to discuss how the rest of reagents come into play in the overall process. Very first step is called phosphorylation of glucose. Phosphorylation means attachment of phosphate groups, as you can see here. I don't know if you can see it properly, but you have phosphate group attached to 3 different oxygen that exists as a resonance structure. One of the characteristics of this phosphate group is that it's heavily charged, negatively charged. Okay, and 2 of these phosphate groups gets attached to number 1 and number 6 carbon here next to oxygen to form what's called hexose bisphosphate. Hexose just means that hexose means 6 carbon containing sugar. Okay, and you can see that 1, 2, 3, 4, 5, 6 carbons, and these 2 phosphate from 2 different ATPs are now being attached here. So the reasons why phosphorylation occurs, well, first of all, is because phosphorylation occurs to stop any free diffusion of glucose molecules out of cytoplasm. As you know, cell membrane is made up of phospholipids, and phospholipids is negatively charged. So since these phosphates are they are also negatively charged, they repel from or they can't go through the cell membrane. So that's one of the roles of these phosphate groups, and you will see that this phosphate later gets donated to form ATPs. So you'll see that later how this comes into play. Okay, and next step